Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at a library for graphic window-based splash and progress screens. In this series of videos I'll be covering the creation and use of libraries. So you might ask, why use libraries? Why not just write code whenever you need it? Well, if you're writing a lot of applications, having common libraries that contain functionality that you use often will save you time, both coding and testing. It will also make your code more readable and therefore maintainable, which is always a good thing. We have in the past done a couple of videos on splash and progress screens, but for the PowerBasic Windows compiler. There may well be times that you need such screens in the console compiler. And what we're going to do today is we're going to create some library routines to allow us to have a graphics window to appear either from within the Windows compiler or the console compiler. So we're going to create a new library and place it in a file called graphics/progress. Today we're going to concentrate with the creation of a screen which will display the progress in a progress bar. So in order to do this, we're going to create three functions in our new library. One to open the graphics progress screen, one to update the screen, setting the percentage to a particular level, and a final function to close down the graphics window. So first of all, we will create our Open Graphics Progress screen. In your application, there may be more than one graphics window created during the duration of your application. As each of these graphics windows is generated, you will have a handle to that screen. So we will first create a local variable which will be the handle to our graphics screen. This will be declared as a double word, a D word. When we call our new function, Open Graphics Progress, we will get back from that function the value of that window which it has created. We will also want to put some text at the top of the graphics window. And ideally, we'll want to tell the function where on the screen to place that graphics window. These X and Y coordinates can be optional, and we can let the function default to somewhere on the screen if we do not supply them. So we will need a minimum of 2 parameters and a maximum of 4 parameters to this function. So let's assume for the moment we're going to set the X and the Y locations to be 100 by 400. So the call to our function will look like this. The first parameter being the graphics window handle, which will be returning from the function. The next will be the text we want on the top of the graphics window, and the next 2 coordinates are the X and Y coordinates we wish the drawing of the graphics window to commence at. So now that we've got that far, let's create this first Open Graphics Progress function. So here is the beginning of our new function with the 4 parameters. The first 2 parameters are mandatory, the handle for the graphics window and the text to appear at the top. The next 2 parameters we're using the optional word to say that if these parameters are given, we will take them. If they are not given, we will still accept the call to the function. We can detect whether these X and Y coordinates have been given by using the isMissing function. We will create 2 local variables, a start X and a start Y. If isMissing for long X is true, in other words, if this variable here is not passed on the parameters list to the function, then we will default to X and Y being 50. If the values are given, then we will take whatever we've been given and we will populate start X and start Y with those values. We can now attempt to open our graphics progress window. We can do this quite easily using the words graphic window. followed by the X and the Y coordinates, start X and start Y, which will tell PowerBasic where to start drawing this particular window. The next two coordinates are the ending coordinates of the window, the bottom right hand corner, followed by two hwin. Hwin, of course, is the dword variable which will contain the handle of our window. As this is going to be a progress window, we don't want the user having the ability to close the graphics window. So we can use a graphics window stabilize command to ensure that the user does not have the option of closing the window. Now that we've created the window, the next thing to do is to attach it. This allows any future drawing operation to be directed towards this specific window. I'm also going to use the redraw option to ensure that nothing is drawn on the graphics window until we issue the graphics redraw command. And now on this window, I want to draw a progress bar. So we're going to draw a box inside which this progress bar is going to be drawn. This takes a number of parameters, the first being the coordinates where we start drawing the box, and the second being where we end drawing the box, and the 20 is the amount of rounding we've got on the box corners. We can then designate two colours, the first being the colour of the lines of the box itself, and the next colour is the fill colour of the box. The final parameter in this case is a 0, which means we're going for a fill style of a solid fill. And our final command within this function is the command to tell PowerBasic to redraw the graphics window. So if we try running our application now, we will get a sample graphics progress window displayed on the screen. So this is the beginnings of our splash screen. So now that we've effectively opened our graphics window, we want to do something now to close the graphics window off. So we will create the third function, the close graphics progress, which will terminate the graphics window itself. This is a very simple function. It takes a single parameter, which is the handle of the graphics window itself. And then by simply using the graphic window end command, followed by the handle of the window, this will close our window down. So if we add this to our program with the hwin parameter and run the application now. Now the graphics window is appearing and disappearing very quickly. This is because we have no code between these two functions. Normally, you would expect some kind of processing to happen between these two functions. So to simulate this processing, we'll put a 2-second sleep command in. Sleep 2000 will sleep for 2000 milliseconds, 2 seconds. So if we run the application now, it will display the progress window for 2 seconds and then disappear, and then allows the program to close down. So how are we going to set the update graphics progress function to work? First of all, we'll do some simulated processing within our main application. We're going to do a for next loop from 1 to 10 to simulate each 10% of the work actually being done by our application. So we're going to declare 3 variables. The first being the value. This will be the percentage complete for what we are actually processing. The second is we're going to use as a progress loop. This is going to be part of the for next loop that's going to run from 1 to 10. Additionally, we may want to display some message above the progress bar in our graphics window, mainly to tell the user what's actually happening. So we're going to do a for next loop now, from long R equals 1 to 10. This will simulate 10% of our progress. And each time we run through this loop, we will add the value 10 onto the value variable. So it will start off by being 0, go to 10, 20, and so on until it gets to 100. And we can display a message to the user conditionally to tell it how far we've actually got. So if long R is less than 10, we can tell the user we are still processing and what percentage our processing has actually achieved. Once long R becomes 10, we can tell the user we have now completed processing. So this can be done with a simple if command. This populates the message variable. So now that we have that in place, we can now attempt to make a call to our update graphics progress function. And we'll be passing it two parameters, one being the message we wish to display to the user, and the second being the value of the progress bar. So having called the function to update the graphics progress, we will then sleep for half a second, 500 milliseconds, and then we will go on to the next iteration of the long R variable. This will simulate some processing happening in your main application. And before closing down the application, we'll put a sleep in for 3 seconds. This will allow us to see the very last message on our graphics window. So now all we have to do is to create the new function to update the graphics progress. The purpose of this function is to amend the value in the progress bar. It will do this by drawing a filled-in box. We're going to make this box red in colour to indicate to the user what the progress is, and we'll also display the text inside our graphics window. So we will need a couple of variables to keep track of what we're doing. So I've created 3 variables, start, top and %. The start is to indicate where in our graphics window the bar is to begin to be drawn. Top is the final destination, and % will be the length of the bar. So we can set top to be 500 and the start to be 17. If the value passed in from the calling function is greater than 100%, then we will force the value to 100. And we will now calculate the %. This is the maximum size of our box as defined by the value the user has passed in. And note here we're using the integer division. We're not interested in decimal places, just in whole numbers. We now have enough information to draw our graphics box. And as we did before, we're defining the top left-hand corner and the bottom right-hand corner of the box we wish to draw. We're drawing the outline of the box in black, the fill colour is red, and it's going to be a solid fill, hence the 0 as the last parameter. As we want to print a text message from the user on this graphics window, we can use the graphics print command to actually put that message in. But first we will set the position at which that print is going to appear. And then finally we will give a graphics redraw command to command PowerBasic to redraw the graphics window. So now that all that is in place, let's try running the application. And there is our progress bar, with the progress bar advancing 10% of the time until it is completed. The text on the graphics window though is slightly smaller than I would like it, so we're going to increase the size of the text by setting up a font in our graphics window. We're going to create a global variable inside our library called progress font. This will be a double word. This is going to be the handle to the font we're going to designate on our form. In the function that opens the graphics window, we will define a new font. We can do this quite easily by using the font new command, followed by the name of the font and the point size of the font itself. The other parameters we'll leave just as the defaults for the moment, but you can use this to make your font bold, italicized, and so on. And we're passing the output of that to our handle. This will be used later to actually close down our font. Having created the font, we now have to tell PowerBasic that we want that font used specifically for this graphics window. So after our attach command, we will put a command in to set the graphics font. And now that we have that set up, when the function is called, our font will appear as Courier New 18 point. And just to be tidy, to free up the space we've actually designated in memory for this font, when the graphics window is closed, we will end the font. This is done quite easily by using the font end command, followed by the handle of the graphics font. If we rerun the application now, we will see that the font is much bigger and much more readable. So we now have a generic splash screen that operates quite happily in the PowerBasic console compiler which we're currently using. But how does it look in the Windows compiler? Can we use exactly the same code without any change? We are now in the PowerBasic Windows compiler. We've loaded up exactly the same code. This will open the graphics window, run through some simulated processing, and periodically update the graphics progress before closing down. If we run our application now, we will see our graphics window appears quite happily and goes to completion. So we now have a library which works quite happily in both the console compiler and the Windows compiler. If you're writing Windows applications, you may quite often need to give the user a progress bar when your application is busy doing something and you want the user to sit and wait till this has been completed. In the console compiler, many of these types of applications are run with no user interaction. But if you do have one that does involve user interaction, this gives you an easy way of actually giving a progress bar to the user if the application is doing something that is quite time consuming. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.